So we are starting. So this week, we're looking at 3D shapes. So we're going to start with a dinner activity, just to get your brains working and thinking. So you've got 5 minutes to attempt as many questions as you can. Hopefully writing down some spare paper you might have, etc., etc., etc. So starting now. Thank you. If at any point you need to ask a question, um, please can you write it in the chat. You can do that by pressing the button which looks like it says show conversation, and you click that, and then you can type to ask any questions as we go through. Just so you know as well, all these lessons are with use without a calculator, so please don't use a calculator to do question 2, for example. Why can't people join?
Walk on.
It's odd, we've got some people that can't join the meeting for some reason, even though I'm sure the meeting is going ahead. Those still working, got 1 minute 40 seconds to go. So assume that everyone is trying. Yes, joining through the calendar might help. Thanks for that bit of advice. 45 seconds left. Oh, sorry, it disappeared. Ten seconds left. Okay, and that is time done. So, please mark the corresponding answers to the questions you did. See how you did. Right, so moving on, I know there's still people trying to get onto the lesson. We're going to have to just plow on for now. So, for this lesson, you need some paper. Anything will do, but obviously line or square is the best. And if I'm going too slow or too fast, let me know in the chat, but try and be patient with the rest of the class. We've got potentially the whole of year 8 on this lesson at one time. So you can always, if it's going a bit too fast, it's going to go into the Charter YouTube page. So you can always watch it back there. So we're just going to recap of 3D shapes. So what is the name of this shape shown? Can you write it in the chat, please? I know there's lots of traffic in the chat in a minute because some people are trying to get in. But if you can write in the chats what you think this shape is. Yeah, lots of people are going to write, yeah, perfect, well done. It is a cube, well done. Next shape, can you write down in the chat what you think this is? This shape is? Yeah, good. Good, good, good. Good, 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 good. Yes, it is a cuboid, well done. Next shape, another 3D shape. Can you write down what you think this shape is? Yeah, good, good. Some people still answer the previous one. That's okay. Good, good, good. Yes, all correct. It is a cylinder. Well done. What is the name of this shape shown? Again, please write it in the chat. Yes, correct. It is a yeah. Well done. Yes, it is a square-based pyramid. Well done. Next 3D shape. Sorry, I'm going a bit too quick for some people. Yeah, the notifications are popping up quite quickly. I'm still managed to. I mean, I've got the chat on my phone as I'm teaching from the laptop. Hopefully, people can still write. Yes, everyone is correct so far. So it is a tetrahedron. Also triangle-based pyramids, but the mathematical term would be tetrahedron. Well done. Next shape. Or not quite? Think about the shape at the bottom. So the next one, what is the base of the 3D shape? It's a pentagon, so it would be a pentagon-based pyramid. Well done, you've done that pentagonal-based pyramid. Next one. Think about the shape here and think what sort of type of 3D shape this is. So again, we've got a pentagon. Last one was a pentagon-based pyramid. This one obviously isn't a pyramid. So this one here would be a, okay, there is a typo. This isn't a hexagon. It's obviously a pentagon prism, not a hexagonal prism. Sorry for the typo. Although if this was a six-sided shape, it would be a hexagonal prism. So apologies for the typo. And lastly, obviously it's a circle, but it's still got some special sort of shading. What type of 3D shape would this be? Yeah, lots of people get it right. Yeah, perfect. Well done. It is a sphere. Well done. Cool. And I just go through these last ones really quickly. So we've got a triangle. It forms, it's a prism, so it would be a triangular prism. And that's all those shapes done for now. So the flat surface only 3D solids are called faces. So the flat surfaces and the 3D solids are called faces. So if I look at my cube on the left-hand side and my cuboid on the right-hand side, they both have 6 faces. So they've got like one at the front, one at the back, one on the left-hand side, one on the right-hand side, the top and the bottom. That makes 6 faces in total. And again, the cuboids exactly the same as the front and back faces, which make 2, the left and right faces, which make another 2, and the top and bottom faces, which make another 2. So 6 faces in total. So we go cuboid 6 faces, cube 6 faces. Now we've got our pentagon-based pyramid back. How many faces would that have? So how many faces would the pentagonal-based pyramid have? Feel free to write it in the chat. Sorry, people still having issues logging in. Or combination between 6s and 7s. Some of you are right, so some of you are wrong. So we look at a pentagon-based pyramid. At the bottom, we've obviously got one face, but then for each side where it goes up to the point, it says 5 sides to the pentagonal-based pyramids. So we've got 1, 2, 3, 4, 5 around the sides, and another one at the bottom. So it would be 6 in total. 6. If it was a hexagonal-based pyramid, it would be 6. So if this was a 6-sided shape at the bottom. So how many faces does the shape have that's circled? So we've got a circled shape here. How many faces would that have? Again, write it in the chat, please. Sorry, the notifications are a bit annoying. I see there's a way to disable them next week. Perfect. So this one here, we do have 1, 2, 3, 4 around the side. And at the bottom, we've got the square, which will make 5 faces. Well done for those got it correct. Next one, my tetrahedra, the triangle-based pyramids. How many faces would that have? Again, write it down in the chat. Yeah, good. Yeah. Don't know why there's an echo. Sorry, there's an echo. Yeah, perfect. Lots of people have got the correct answer. It is 4. You've got one either side going up to the point and one at the base. Next one we've got our pentagon prism. How many side faces does this have? Yep, good. Don't know why I'm echoing. I do have a mic, it's attached to my laptop. Although I can't actually hear myself back, so. Has 7 well done, yeah, good. And lastly, the triangle prism. Yeah, good. People are getting this right. Yeah, good. Yeah, well done. It is 5. You've got 3 faces around the outside and then 2 identical triangles either side, which makes 5 faces in total. Perfect. So this last one, I wonder if this will trick anyone out. How many faces does the shape have shown below? So it's a cylinder. Lots of people that are going for 3. At least one person's got the right answer. So the answer is, lots of people change the answer after that. It is actually 2. So I know some people are saying you've got the circles either side, which make up 2 faces, and then the rectangle that goes around, which makes up the 3rd face. But the flat surfaces on a 3D solid are called faces, and this isn't a flat surface that goes all the way around. So the curved face of the cylinder doesn't count in this case, because it are only flat faces. So well done those who got 2 faces for that. I understand why you got 3, because if you were to see the net of this and to lay it flat, you would see 3 separate pieces of the cylinder, but it's only flat surfaces that counts, which are called faces. Next one, so Mina could have looked at other properties of her shape, so we're not just looking at faces here. The other properties include faces, edges, and vertices. Vertices is just the maths words for corners, and angles. So several different bits and pieces could be looked at for a 3D shape. So we know that the shape was a rectangular prism or a cuboid. There were 6 faces, but how many edges are there? The edges is simply where 2 faces meet. So the edge of a 3D solid is where 2 faces meet. So where they meet, they form a line, don't they? So where these 2 faces meet here, the top and the front and the top, they create a line here, and that line there would be an edge. So how many edges does it have? 1. Oh, just give me the answer there. So 1 here. So we think about going around the outside of the cuboid, we've got 1 there. 2, 3, and 4, joining up each side of the square either side. 1, 2, 3, 4. And if you look at the square itself, you've got 5, 6, 7, 8. So you've got 4 this side. You've got another 4 on the left-hand side as well. So that totals up to be 12 edges in total. So there are 12 times where 2 faces meet on the cuboid. Vertices. So vertices are a vertex is in a 3D solid. It's a point where 3 edges meet to form an angle, and it's also called a corner. And the plural of vertex is vertices. So, how many vertices does this shape have where the edges meet up? And how many corners essentially? So, We've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 that we can see, and there's also an eighth one behind that you can't see. I don't know why this circle is here. That's just throwing people off. But there's 7 corners you can see, 7 vertices you can see, and there's also one hidden behind the shape. So well done, those in the chat. It is 8 vertices. Well done. So what I'd like to have a go at really quickly is for each of these shapes, record the number of faces, edges, and vertices, and what do you notice. I'm just going to give you 5 minutes. Hopefully you've got a bit of paper or something you can jot down, and while you're doing that, I'm going to try and work out why my mic's a bit weird. So 5 minutes, I'm just going to jot it down now. How long is this? It's not anymore. Your mic is fine now. Oh, okay. Well, thanks. So 5 minutes. How long is the lesson? It should run until latest 10. So you're just answering the questions. You don't have to write it down in the chat for this part. Yeah, every Monday 9:15 till 10. Just when the lesson is for everyone else who was listening. Just under 2 minutes to go. 40 seconds left. Ten seconds left. And your time is up. So, going for each of the answers. Again, if you didn't have time to finish off this task, you can watch it back later when it goes on to YouTube and that. So, you've got 6 faces, 10 edges, and 6 vertices for the pentagonal base pyramid. The cube, we've already basically done 6 faces, 12 edges, 8 vertices. And the tetrahedron, 4 faces, 6 edges, and 4 vertices. The main reason is for that is with the videos and the faces is if everyone used their mic and everyone used their cameras, the bandwidth, you wouldn't get a smooth lesson, you wouldn't be able to hear me, it would be lots of buffering, so you always have to turn off your mics and cameras basically. Next one, 5 faces, 8 edges, and 5 vertices. Next one, 7 faces, 15 edges, and 10 vertices. At the bottom here, 2 faces and 2 edges, and 0 vertices, there's no corners. And finally, we've got 5 faces, 8 and 6 vertices. If anyone did a star question, my shape has 5 faces, 6 vertices. How many edges will it have? What shape am I thinking of? That, oh, I'll try the answer for that. I'll come back to that one. So, is a 3D solid with an equal cross section. So what that means is, going back to that question, solid has 3 faces. Solid only has 2 faces because the outside rectangle isn't a flat face, it's a curved face. So a cuboid has either a square or a rectangular cross section which goes all the way through the shape. Triangular prism, again this triangle goes all the way through the shape, and a pentagonal prism, this pentagon goes all the way through the shape. So any point where I cut it perpendicular at a right angle to this shape here, you have the same shape all the way through. A bit like a Toblerone bar, that has that same triangle all the way through, hasn't it? And as you can see from the diagram, that shape goes all the way through, up and down. So what other shapes are prisms? Can you see any other in the classroom? Obviously, you're not in a classroom, most of you aren't in the classroom, but I did an example of like a Toblerone bar. Yeah, so have a think about whatever sort of prisms you can think about in real life. So this cross section, we've got the rectangle. Obviously here, the cross section here is a triangle, and this cross section is the pentagon. You should still be able to see the PowerPoint. Anyone else have any issues with? Lots of people can see it. Okay. Thank you. Yeah, that's good. So I'm not sure the people that are struggling to see it, what having issues. So which of these shapes would be a prism? So we've got shape A here, shape B here, and shape C here. Which of these would be a prism? Write down in the chat, please. Which one you think would be a prism? Good, good, good. Yeah, perfect. Everyone's correct. It is B. If you cut straight through the middle there, you would have the same square all the way through. Well done. A wouldn't do to have a circle, but it wouldn't be the same size circle all the way through. And again, C wouldn't, depending on how you cut it. And it would be a square. The shape of the cross section is the square. Next one, A, B, or C. Which one is a prism? A, B, or C? Good, 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 good. Yep, everyone seems to have done really well. It is C there, well done. And the shape would be a circle. We'd cut it all the way through. Which of these shapes would be a prism? A, B, or C? Good, yeah. Good mixes of capitals and lowercase for that one. And it is uppercase A, which would be a prism. B and C, again, they wouldn't be. You'd get different shapes, so you cut them through at different sections, and it is a pentagon. So what I want you to do, I mean, this will be a little bit tricky to do on paper, but have a think which ones of these would go into the prisms. So which ones of these shapes would be prisms, and which one of these shapes would be not prisms. There's a star question to think about there as well. It'll probably take you like 1-2 minutes to maybe do this in your head. If you want to write it down, of course you can, or copy the shapes down to prisms and non-prisms, but just try and think which shapes are going to which sections. Just a minute for that. And that's time up, so let's have a little look. The cuboid would be a prism. The tetrahedra would be not a prism. The sphere would be not a prism. Cylinder would be a prism. You make sure you're keeping the chat just to stuff around the live lesson. It already gets quite full. The not a prism for the pentagon-based pyramids. Any pyramids essentially wouldn't be a prism. Cube would be a prism. The pentagon prism would be a prism, and the triangular prism would be a prism too. So I don't know we sorted that into those correct groups. So last little bit, we've got an extra ticket to have a go at. Question 1, if you could write down a bit of paper, that'd be great. Which of the following is a sphere? Nice and easy. Question 2, a shape has 2 square faces, 4 rectangular faces, and 8 vertices. Which of the following shapes could it be? Could be more than one, maybe. Question 3, a prism is a 3D solid with an equal blank all along its blank. So just 2 minutes to have a go there. Those questions. Yes, again, please focus on the maths. It's not a place for chatting in the chat. Please use your own individual social medias to do that at an appropriate time. Thank you. One minute to go. For this bit, can you not write the answers into the chats at this moment? Just obviously some people are still working away at it. No worries. 15 seconds left. And that's time up. If there we go, there's the answer for questions. So question 1 was B, was a sphere. Question 2, it could only be a cuboid, I'm pretty sure. And the last one was an equal cross section all along its length. So if you are watching this back later, and any talking doesn't make sense because I'm responding to people in the chat, and that is today's lesson done. So yes, this will be going to YouTube, the Charter YouTube page, so you'll be able to watch it back if it went too fast or too slow. This lesson should hopefully help you with stuff that's in the work booklet. It's trying to cover everything that's sort of in there each week. If you think it went particularly fast or particularly slow, or anything you think could be improved for next week, can you just write in the chat area? It will be starting at 9:15 each lesson and should finish at about 10-ish, around 10 o'clock each day. Not each day, each Monday. So yeah, please tune in next week. And thank you for those who use the chat sensibly and properly. So yeah, speak to you guys next week and have a lovely week.